Good morning, my YouTube viewers. It is Crystal here, and I wanted to give you another code review. This code review is going to be on Kmeans clustering for heart disease analysis, and it's going to be on a community competition with Kaggle. And so what I did was I did the community competition, and I couldn't get on the leaderboard because I entered the competition after the competition had ended. But I'm going ahead and going over the code with you, even though I couldn't get on the leaderboard, because you can submit your score to Kaggle, and Kaggle will grade it, but you just won't get on the leaderboard because you got in the competition after the competition ended. So I created the program using Kaggle's free online Jupyter notebook, and it's stored in my account. But what I will do, I will give you a link to the Jupyter notebook so you can look at the Jupyter notebook if you like. So the problem statement is use Kmeans clustering to identify heart disease. One thing they do is they don't tell you how many clusters to make. And since they don't tell you how many clusters to make, you have to use your best judgment. And so what I did was I used the elbow method to determine the number of clusters to make. And whenever I did the elbow method, I could have had 2, 3, or 4 clusters. So I ran it up on 2 clusters and checked the accuracy, and ran it up on 3 clusters to check the accuracy, and ran it up on 4 clusters to check the accuracy, and I got the best accuracy on 3 clusters. But that's how you do it, and then whenever you do the elbow method, where the elbow is, that's the number of clusters that you're supposed to use. But I just went ahead and checked it on 2 and 4 in addition to that to see if I could get a better score, because I wanted to get the best score I could. And we will be talking about the elbow method in this code review. So after I created my Jupyter notebook, one thing I had to do was I had to import the libraries to use to help the program to run, because the program won't run unless you have the libraries. So we're going to import NumPy as NP, which creates NumPy arrays and performs numerical computations. We imported Pandas as PD, which creates the data frame and processes the data. We're going to import OS, which goes into the operating system and retrieves the files that you're going to need. We're going to import sklearn, which provides machine learning functionality. We're going to import matplotlib.pyplot as PLT, which visualizes the data. And we're going to import Seaborn as SNS, which statistically visualizes the data. So after we have imported the libraries that we're going to need to execute the program, we use the OS library to go into the operating system and retrieve the files that we'll need. And the 2 files that we need are heart disease CSV and sample CSV. So after we've retrieved those files, then what we're going to do is we're going to use Pandas to read the files in. So we're going to create 2 data frames called data and submission. So this is your data file. It's 920 rows by 15 columns. And so we're going to check info. So the info is going to be integers, objects, and floats. Then we look at the submission file, and this is what the format that Kaggle wants to see when you submit your predictions or you submit your clusters to Kaggle. So I checked the value count on the clusters. So submission cluster.valueCounts equals 299 zeros. So there were 299 rows. So you can see that on the data you had, I think it was 920 rows, and on submission you only have 299 rows, so you're only going to be using about a third of the rows. So that makes it a little bit more difficult. So what we're going to do is we're going to check the ID against the submission. We're going to create an extra column called exist. So data exist equals data ID dot is in submission ID data. So you have your 920 rows with an extra column. If the ID is in submission, you get a true. If the ID is not in submission, you get a false. So we do a value count, data exist dot value counts. So you have 621 falses and 299 trues. And so what we have to do is we have to filter out the falses, because you don't want the falses, you only want the trues. So we're going to drop rows that are false. So heart data equals data, data exist equals true. So you're filtering out all the trues. So everything that's true is going to be in the new data frame heart data. So now we have 299 rows by 16 columns. So now we have all of the rows that are in the submission file. So we're going to check for null values. So you see we've got quite a few null values that we have to impute. So we're going to impute the null values. If the data type is object, we're going to put not known in the null value. If the data type is int64, we're going to put the most frequently used value in there. If the data type is float, we're going to put the mean there. But we could have put the most frequently used in there if we had wanted to. I mean, in theory, I could take the mean and put mode in there and just use the most frequently used value, but I put mean. And it's your personal choice whether you want to use mean, median, or mode, but in this instance, I use the mean of the column. So here we go, a new data frame with all of the imputed values. Now we're going to drop ID and exist. You don't need ID, and the reason why you don't need ID is because each row is automatically indexed in the data frame, and you don't need exist because that's a column. So we're going to, sorry, let me start all over again. We're going to delete the columns ID and exist from the data frame. You don't need ID because each ID is automatically indexed in the data frame, and you don't need exist because that's the column that we have already made, and it says either, it's all going to just say true anyway. So we delete those columns, so now we only have 14 columns. Now we check info. You can see that we've got integers, objects, and floats. So now what we want to do is we want to encode all of the columns that are objects. But the first thing we want to do is I wanted to check the D type of every column, and the reason why is because I had some difficulty encoding, and because I had some difficulty encoding, I wanted to check what the D types were. So because I had some difficulty encoding, I'll read you the code that I used from sklearn.preprocessing import ordinal encoder. ENC equals ordinal encoder for column in hard data. If hard data call dot dtype equals object, hard data call equals hard data call dot astype str. Hard data call equals enc dot fit transform hard data call dot values dot reshape -1 1 and hard data call. So we bring all that down, pass all these warnings. And so now we have all of the strings encoded. So now that all of the strings are encoded, then what we can do is we can begin, well, after we scale the data set, we can begin the clustering. So after we have encoded all of the data, we want to scale the data set. So from sklearn.preprocessing import standard scalar, scalar equals standard scalar, for call in hard data, scalar.fit transform hard data dot call values dot reshape -1 1 hard data. And then so now you can see all of the data has been rescaled, or it should have been rescaled. It doesn't look like it was rescaled because it doesn't look rescaled to me. So what I'm going to have to do is whenever I finish this code review, because I'm almost finished with the code review, I'm going to say hard data dot call equal up here. I'll say hard data dot call equals, and then, or I could say in place equals true. Either hard data dot call equals or in place equals true. But when I finish this code review, then that's what I'm going to do, because as I look at it, it doesn't look like it's been scaled to me. And then if I'm able to scale it properly, then there's the possibility that I can get a better score, which that's what it's all about, getting the best score possible. So that's one thing that we'll do. I won't do it now because it might take too much time, but I will when I finish the code review. So really, it hasn't been scaled. I didn't do the scaling properly, and part of that reason why is because it was late at night when I was working on this, and the light wasn't very good. So, but I'm going to do it as soon as I finish this code review. I'm going to properly scale it, and hopefully the accuracy will be better. And now what we're going to do is we're going to use the elbow method. And the elbow method helps you to determine the elbow method helps you determine how many numbers of clusters to use. And this is the code for the elbow method here. I got this off of the Statology website. And then we print it off, we visualize the results, and you can see you've got 2, 3, and 4. So I checked it on 2, 3, and 4, and I had the best reading on 3, so that's what I used. And so now we use Kmeans clustering with 3 clusters, and then we did prediction equals Kmeans.labels, and here are the predictions, 0, 1, and 2. And then I prepared the submission. And when I prepared the submission, this is what I submitted to Kaggle. But now that I've done the code review, what we'll do is we'll go ahead and see if we can get this scaling to work, because it didn't take a long time. And we'll see if we can get the scaling to work since we finished the code review. Okay, so we'll try it again. Fortunately, it didn't take a long time to train the data, which is why I'm doing it in the code review, because if it took a long time to train the data, then I wouldn't be able to do it. And last night when I was working on it, I was in bed. I had my laptop in bed, and it was really dark and I couldn't see very well. And I know that's not a good excuse, but that's what happened. So it looks like it's been scaled, so that's good. And then now that it's been scaled, it looks like the elbow doesn't even look like there's much of an elbow, but you can see the 2, you can see the 3, and you can see the 4. So we're going to stick with the 3. And then what we'll do is we'll save our work. So you can see that the elbow is a lot clearer when the data hasn't been scaled. And so now we're processing it. And that's another reason why I like to do these code reviews, because like if I made a mistake or something like that, then I'll pick it up in the code review. So it's finished saving. So we're going to open it in the viewer. Okay. So I've had 17 views so far. Check output. Check submit. So actually, I got a lot worse value when I scaled it than when I didn't scale it. Because if you check the leaderboard is, so I got a worse value when I scaled it than when I didn't scale it. So that tells you something. That tells you that, so even, I'll show you in Statology said to scale the data. But so I scaled the data because that's what Statology said to do, because I wasn't sure. But when I scaled the data, I got a worse reading than when I didn't scale the data. So that's interesting. So what we're going to do is we're going to remove the scaling. And we'll run it again. So you can see 2, 3, and 4. So the elbow was on 2, but I checked it. I checked it on 2, 3, and 4, and I got the best reading on 3. And I was reading something whenever I was studying clustering on Kmeans. It said that it works better if you have an odd number of clusters. But I think that you should use the number of clusters that what it says to use in the elbow method. And there are other ways that you can determine which cluster to use. But whenever I was working on this last night, the elbow method was the method that just came to my head. But there are a number of clusters that you can use. So we're going to go to output. I'm going to go to submit. And so we've got 14.635334. So we've got a better reading when it wasn't scaled. So that's interesting. And that's another thing you're supposed to do. You're supposed to check the data if it's scaled, check the accuracy if it's scaled, and then check the accuracy if it's not scaled. So you can see the leaderboard. I'm not on the leaderboard, but the highest score is 10 and the lowest score is 21. So I'm up there between the highest and the lowest. So that's not bad. So we check our submissions. And so there we go. So we don't have scaling. But what we'll do now, see, this is what I checked with Statology. And with Statology, he said to use scaling. That's what this guy that runs Statology said to do. But what we can do is we can do that. We can ask the question of Google. We'll just ask the question of Google. It said you need to pre-process and scale your data so that each variable has a comparable impact on the clustering outcome. But we scaled the data and we didn't get a good reading. So here's the question. Should I scale data for clustering? It says yes. Clustering algorithms such as Kmeans do need feature scaling before they are fed to the algo. Since clustering techniques use Euclidean distance to form the cohorts, it will be wise to scale the variables having heights in meters and weights. So this is what I would suggest. I would suggest that you scale the data, you check the accuracy with scaled data, and then you don't scale the data, and you check the accuracy with the data that's not scaled and then you select the best algorithm to use. So that's basically what I would suggest that you do, because that's what I did. I scaled the data because this guy on Statology said to scale the data, and even Google says to scale the data. But when I scaled the data, I got a lower reading than when I didn't scale the data. So that's what I would suggest you do. Try it with scaled and try it with unscaled, and then go with the best reading. That's what I would suggest. And I also got 2 comments. It said, here's 2 comments. It says, good analysis about Kmeans clustering, and I got an upvote. And then I got, that was interesting work, thanks for sharing. Because another problem that you have, especially on these community competitions, is people don't share their code because they're afraid that if they share their code that, people are going to do better than them, so they don't share their code. Well, I do share my code, and the reason why I share my code is because I'm a content creator. But if my machine learning skills ever get good enough to where I feel confident to enter a competition and I feel like I have a good chance on winning, maybe I won't share my code, because they say that people that win these competitions don't share their code. So we'll just play it by ear and see what happens. But I've done the code review for you. I've showed you how to do the code review without scaling. I've showed you how to use the code review with scaling. And so now it's up to you. So when you do your Kmeans clustering, you do it with scaling, see what your accuracy is. You do it without scaling, see what your accuracy is, and then pick the best one. So that's what I would suggest to do. So I'm going to go ahead and conclude this code review because I've been speaking for 25 minutes. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more videos for you in the future.